Hello everybody, welcome to mathskpreet. In today's lesson, I'm taking this topic HCF and LCM, a very important topic for competitions. I have already uploaded few video related to this topic. I'll put the links of the related videos in the description box. Please go and check that videos as well. So before doing the important question of this chapter, let's recall the definitions related to it first. So what a factor is? If I have two numbers A and B such that A is dividing B exactly as I told you, means remainder is 0. So A will be known as factor of this number. For example, 2 is dividing 100, 2 is dividing 250. So here remainder is 0. When 2 is dividing these two numbers, that means 2 is a factor of these two numbers. What else? 5 divides 250. Okay, so when remainder is 0, such numbers that divisors are known as factors of that number. So this means divisors. Which divisors? Where remainder is 0. What are the multiples? So if I have a number A, multiples of A are what? A into 1, A into 2, A into 3. It's clear from the definition. On multiplying a number with the counting numbers, we will get multiples. Like I have say 3, 3 ones are 3, 3 to the 6, 3 to the 9, 3 4s are 12, 3 5s are 15 and so on. These are all multiples of 3. Very simple. So HCF means highest common factor, and the other name for the HCF is GCD. GCD is greatest common divisor. Factor and divisor both means same. Factor is what? Exact divisor, and third name is GCM. That means greatest common measure. So there are two methods to calculate the HCF of two or more numbers. First method is prime factorization method, and second is the division method. See, if I have these numbers 6, 9 and 15. I have written the prime factorization for these three numbers. So what is HCF? HCF is basically minimum power of all the common factors. All the common factors. Clear from the name common factors. Here highest or greatest. In highest and greatest, we will take minimum power of all the common factors. So calculate the HCF of 6, 9 and 15. So here common factor is what? In all the three, the common factor is 3, and the minimum power of 3 is what? 1. So 3 is the answer for HCF of 6, 9 and 15. Why? 3 is dividing 6 exactly, 3 is dividing 9 exactly, 3 is dividing 15 exactly. So this is my answer for this HCF. Now let's see what is LCM, least common multiple. Least common multiple is given by maximum. It's reverse, least. So here we'll take maximum. Maximum powers of all the factors, not common, of all the factors. So I'm taking these three numbers again. Here to find the LCM of 6, 9 and 15, I'll take all the factors, means 2 is a factor here for number 6. So we will write 2. What is the power here? Maximum power is 1. Fine. Next factor is 3. Maximum power for 3 in all the numbers is 3 square. From here I am writing. And the other factor 1 need not to write, rest is 5. Maximum power of 5 is what? 1. So this is the answer. 3 is a 9, 9 5s are 45, 90. So here 90 is the least common multiple. I will check our answer. 6 will divide 90. Fine. 9 is dividing 90. 50 is dividing 90. So this is a multiple actually. So here, as I have told you, if A is dividing B, exactly A is the divisor or factor and B is what? Multiple. So here we are getting least common multiple just by taking the maximum power of all the factors. So let's see how to find the HCF and LCM by the division method. First see the question here, find the HCF of these three numbers. So here 1215 and 1134. I'll take these two numbers, the greater numbers first. Keep the greatest number as dividend and the second greatest as the divisor. Then keep on dividing in a way that when you are getting the remainder, then take this divisor as dividend, keep on dividing. If the remainder is 0, then this divisor will be the HCF. So 81 is the HCF for these two numbers only, but I have to calculate HCF for these three numbers. So the second pair I'll take is this HCF and 513. So to calculate the HCF of these two numbers, I'll take 513 in the as dividend and 81 as the divisor. I'm dividing this and getting the remainder 27. When I'm getting this remainder 27, I'll take this 81 as dividend, then keep on dividing. Here I'm getting remainder 0. This means this 27 is the required HCF for all the three numbers. So this is the division method to calculate the HCF of numbers. Let's see the division method to find the LCM. Here we'll keep the given numbers in a row and we'll divide these numbers with a number where at least two numbers are divisible by the same number. So here 2 is dividing all the four numbers. Then these are the remainders. These remainders are again divisible by 2. How many? 8, 12 and 18. 27 is not divisible, so keep it as 27. In such a way, divide or repeat these steps till we get the last numbers as prime numbers. That means the number should not be divisible by any of the other numbers except itself. So LCM here is what? Product of these numbers we are left with. So here LCM is what? 432. Let's see this question. It's saying that find the greatest number which on dividing these two numbers leaves remainder 6 and 5 respectively. So it's asking me to find the greatest number which on dividing. Dividing means we here have to find HCF because dividing means divisor, and exact divisor means factor. So we are doing the chapter HCF and LCM, and according to that I have to find HCF here. So these are my two numbers 1657, 2037. Find the greatest number which on dividing these two numbers leaves remainder 6 and 5. I am not able to find such a number which on dividing these two numbers is leaving the remainder 6 and 5, but I am capable of finding such a number which on dividing these two numbers leaves remainder 0. So I can find such a number which on dividing these two numbers can leave remainder 0. This is only possible when I will subtract 6 from here and 5 from here. Only then I can find the HCF of these two numbers. So this will be my solution. Let's see how to perform. To solve this question, I'll write to find HCF or HCF of 1657 minus 6. This was the remainder. I'll subtract this remainder from this number, and 2037 minus 5. This was the remainder for this number. I have to calculate HCF of these two numbers to reach my answer. 1651 2032. So I have to find the HCF of these two numbers. Now we know that here we will use the division method to calculate the HCF because the numbers are greater. So here HCF by division method I am simply writing. You can perform that method by yourself. By division method, HCF of these two numbers will be 127. HCF of these two numbers will be 127. I hope you understood the logic. Let's see this question. Find the largest number which divides 62, 132, 237. Once again we have to find the largest number which is dividing these three numbers. Dividing and largest means we have to calculate GCD, HCF or GCM. Leave the same remainder. In the last question we have seen the different remainders, and here in this question on dividing these three numbers by that largest number which we have to find, remainder is same in each case. How we will do such questions? See the logic. If I am dividing 62 with the number, I am getting some quotient and remainder is what? R. Similarly, I am dividing this 132 with this number because I have to find the largest number. I am getting some quotient and remainder is what? Again same, R. In third case, 237, this is my number, this is my quotient and remainder is again R. See, this is my N. in each case. I have to find this n basically. So I can write 62 as divisor into quotient plus remainder. Fine. 132 can be written as divisor into quotient plus remainder. 237 can be written as this divisor into quotient plus remainder. So every time I am getting same remainder, to make this remainder 0 according to the requirement to get a factor or highest common factor, what I will do, I will just subtract from this equation 132 minus 62 will give me n times q2 minus q1. This r will be r minus r will be 0, so there will be no remainder. Fine. And 237 from this equation I am subtracting this equation, I am getting q3 minus q1 with the remainder 0. From here I can subtract 237 minus 62. I'll get this number q3 minus q1. This was my q2. So when I will subtract these equations, I am getting remainder 0 and some divisor which is common in all the cases. So here I have to choose these numbers to find the HCF for. This was the logic to find such largest number. Such means that is dividing these to leave the same remainder. Have to find HCF of what? 132 minus 62, 237 minus 132 and 237 minus 62. For these three numbers I have to calculate HCF. So this is what this is equals to HCF of 0 and 7, 70, 105 and 175. So you can choose any method to calculate this HCF, whether the prime factorization or the division method. So ultimately you will get your HCF as 35 for this question. So this is my answer. So in the questions where we find such words like highest, greatest, largest, biggest, along with the numbers like divides or dividing, in such pairing of words we have to find the HCF or GCD or GCM for the question. And in the questions where we find the words like lowest, least, smallest, along with the divisible by, in that questions we have to find the LCM. We must know where to find the LCM and HCF after doing so many questions related to this chapter. So if you're liking my videos, please share with your mates and friends. Subscribe for such more videos. Have a good day. Thank you for watching.